So now we shall study about isometric projection. So isometric projection, it is a method for visually representing any object in 3 dimensions, okay, in engineering drawing. Okay, it means that, so in the previous problems we did about orthographic projection. Orthographic means if any object has to be represented on a sheet or a paper, so it has to be represented by its front view and top view and side view. So you need to show it in 3 views, okay. To describe that drawing, you need to show that in 3 views: top view, front view and side view. Okay, so in isometric, so in a single view you can show all the 3 dimensions. So for example, so you can see this, okay. So this is a object, this is a solid object, so we call it as 3 slabs placed one above the other, okay. So if you construct a line like this, it becomes a rectangular slab. So if you construct a line like this, it becomes one more rectangular slab, and this will be one more rectangular slab. So 3 slabs placed one above the other in the form of steps, okay. So this is the actual object, okay. It is a solid object, it is an actual. So by showing its view in orthographic means you need to show the front view. So in front view it looks like this, you have to show like this, and in top view you have to show like this, okay. In side view how it looks, you have to show like this. So these are the 3 views that are going to represent the engineering drawing orthographic projection. But whereas in isometric projection, so you can show the image in a realistic view. So this is a realistic view. So in all your textbooks and all, they will show the isometric projections only, because it will be easier to understand the drawing, okay. In a single view you can understand the drawing. So in this chapter you are going to learn how to construct isometric projections, okay. So in this isometric projection, so in your solution book they have classified into 2 types, that is 2 solids and 3 solids problem. In 2 solid problem, so 2 solids are placed one above the other, okay. In 3 solid problem, 3 solids are being placed one above the other. So first we can learn about how to construct isometric projection for 2 solid problem and 3 solids problem. So before going to 2 solids and 3 solids, you must be familiar with constructing single solids, okay. So after being familiar with single solid construction, then you can place 2 solids one above the other, and then 3 solids one above the other. So this is the iso grid sheets. So this is the iso grid sheet. So you can see that in your sketchbook at last they will be the print will be like this. So these are called as iso grid sheets. Isometric grid sheets, and these are the construction, how to construct an iso grid sheet. So this is an example for 2 solid problem. So you can see that the base solid is a square slab, okay, square slab, and on the square slab there is a triangular pyramid has been placed at the center. So this is an example for 2 solid, combination of 2 solid. A pyramid has been placed on square slab. In the question they will give like that. So you need to analyze the question and then you need to construct this. So on the iso grid sheet only you need to construct, okay. So if they have given 80 mm square slab means you have to choose 8 divisions or 8 boxes here, okay. 1 2 3 4 5 6 7 8, okay. It represents 80 millimeter in iso scale, okay. So iso scale is different to the normal scale, okay. In iso scale, if it is 80 mm means in iso scale it will be somewhat lesser. I explain that. So but this is the iso grid sheet. While constructing an iso grid sheets, 80 mm means you have to choose 8 boxes, 50 mm means you have to choose 5 boxes, 1 2 3 4 5 like that. And this is one more combination of 2 solid, square base prism and a cylinder has been placed like this. Okay, so these are the examples for isometric construction, and this is the iso grid sheet. You can find that in your sketchbook at last. Okay, so in isometric construction, the object is tilted 30 degree. Okay, so that what happens, you can see all the three dimensions when it is lifted certain angle at certain angle, so that you can see all the three dimensions. So while tilting that at certain angle, so the object's dimension may vary. Okay, for the observer it will vary, so it will be somewhat, the observer will appear as a reduced. Okay, so how many times it is reduced means 0.816 times it will be reduced for the observer. For example, if the one of its edge is 50 mm means if it is tilted 30 degree, so what happens for the observer, it will be in the form of reduced by 0.816. 50 into 0.816 is 40.8 millimeter. For the observer in iso scale it looks like 40.8 millimeter. So whenever you construct isometric drawings, whatever the given dimensions they will give, you have to multiply with 0.816. Okay, so it will be the iso scale, we call it as iso scale, whatever the dimensions they may give. So this is standard 0.816, you must multiply with this value. So by multiplying with this 0.816 you will get the iso scale. Okay, so this iso scale must be used for all the dimensions in isometric construction. So if you are constructing in a plain white sheet, okay, if you are constructing in plain white sheet, you must convert all the dimensions and multiply by multiplying with the given dimension by 0.816, then you need to construct. For example, if you have been asked to construct a cube means it looks like a square based prism itself. Cube, all the sides are equal. 50 mm cube means all the sides are equal. So 50 mm cube means you must construct that cube by the given dimensions 50 mm. So you must construct all the dimensions by multiplying with 0.816. 50 into 0.816 and all the sides. So it will be 40.8 millimeter. Take that 40.8 millimeter and then construct. I'll explain that later. And next, this is for white paper while constructing in white sheet. So if you are going to construct in iso grid sheet, okay, isometric construction on grid sheets. Okay, so this is for grid sheet. If you are using iso grid sheet means, as I have shown here, this is the iso grid sheet. Okay, so if you are using this grid sheet means no need to convert to iso scale, it has been already converted. Okay, so each box represents iso scale. This will be not 1 centimeter or 10 millimeter, it will be 0.816 multiplied. Okay, so if you are using iso grid sheet means no need to convert that. Keep it in mind. If you are constructing in a white sheet means multiply all the dimensions by 0.816. If you are constructing in an iso grid sheet means no need to multiply with anything. Whatever the given dimension, you can directly take that. If any drawing is of 50 mm means, if you are using iso grid sheet means just take 5 mm. 1, 2, 3, 4, 5 boxes. Okay, like that. So now let us construct a simple drawing. For example, so this is a simple question. Construct an isometric projection of square slab of 50 mm, all the sides, and thickness 20 mm. Slab means it will be having some thickness, so it is 20 mm they have given. So it is just an example for constructing isometric projection of a single solid. Okay, so if you are familiar with constructing single solids, you can go for combination of 2 solids and 3 solids easily. Okay, so now construct an isometric projection of square slab of 50 mm and on thickness 20 mm. So now take a baseline and next from any point take 50 mm, angle is 30 degree. Okay, and next from here also 50 mm, angle is 150. So it means that it must be 30 degree. Here also this must be 30 degree on either sides. So now two edges we have constructed, other two edges we need to construct. So in grid sheets you can find the grids easily. You can use that grid and take again 50 mm, angle is 150. You can join easily the end point. Okay, so while constructing on a white sheet you can again take a reference like this, and then it must be 30 degree to this one, like this. Okay, here also you can take a reference. On white sheet you can construct like this. On grid sheets it will be easier to follow the grid lines. Okay, so now this is the base, what I constructed, the base of the square slab. For example, if I name this, you'll be understood. So this is A1, this is B1, this is C1, this is D1. So now I need to construct top face. So to constructing top face, what he has given, thickness is 20 mm, 20. So one more thing I want to tell you, 20 mm must be multiplied with 0.816 here also. So whatever the given dimension, 50 mm, so 50 into 0.816 I must take. I am constructing on a white sheet here. Okay, so but if you are using grid sheets in manual construction, no need to convert that to 50 into 0.816. Directly you can take 5 boxes. Okay, so now I am not converted here, but last I will convert. Okay, next 20. So now construct in computer construction, construct as per the actual, at last you can convert to isoscale. 20. I have constructed a square slab. Okay, square slab I have constructed, and now I will convert this to isoscale. So converting isoscale, so I'll find here, go to tools, customize, convert to scale, that is scale factor is 1 year. I have constructed as per the 1:1 scale factor. Now I am reducing that to 0.816 times. So instead of converting each and every dimension by 15 to 0.816, I have reduced the entire drawing after constructing and multiplying with 0.816. Okay, so this consumes time. If I keep on reducing this each and every dimension by 0.816 means it consumes time. So that what I did means I have constructed all the edges by actual dimension, then I have converted by using isoscale. Okay, so this is for while constructing manual on a white sheet, each and every dimension has to be use calculator, and whatever the given dimensions must be multiplied with 0.816. Okay, So if you're using grid sheet means no need to convert anything, directly use the boxes. 50 mm means 5 box. Okay, so now this is the converted and actual isoscale square base square slab. So now you have to remove the unwanted lines. Okay, there is no question of showing hidden lines and all, directly you can erase that. So now this is the square slab isometric view of square slab. So now you can show the names. If you want you can show that, otherwise not needed. Okay, A, B, C D are the top corners, A1, B1, C1, D1 are the bottom corners. This is the construction of isometric view of any given solid. So now one more construction. Construct an isometric projection of rectangular slab of given dimension 60 by 40 by 20 millimeter. Okay, mm by 40 mm by 20 millimeter. So I need to construct this rectangular slab in isometric projection. So now, so use grid sheets only. If you don't have grid sheets, go for white sheet. And now we'll construct first the base. I'll construct for 60 mm, angle is 30. Next, this side it must be 40 mm. So if you want you can use baseline. And thickness they have given 40 mm, sorry 20 mm, 20. I will convert this to isoscale. This is the actual scale. Okay, this is the isoscale, and this is I have converted this rectangular slab into isoscale. Okay, so now one more construction, that is construct an isometric projection of cylindrical slab of dia 50 mm and thickness 20 mm. Cylindrical slab means from top view it looks like a circle. Okay, and from front view it looks like a rectangle. So now if it is tilted in isometric projection, that is 30 degree. So how it looks, the circle will be appearing as a ellipse. Okay, so the best example for cylindrical slab is carom board striker. Okay, striker is an example for cylindrical slab. If you place that striker on a table, and if you observe that from top view, it looks like a circle, and if you observe that from front, okay, it looks like a rectangle. In isometric projection, if you tilt that, if you lift that striker from table in 30 degree, how it looks, it looks like a ellipse. Okay, so this is the best example for cylindrical slab. So now how to construct that cylindrical slab in isometric projection means, so now first construct a box. Wherever cylinder comes in isometric projection, you must go for this procedure. Okay, so they have given 50 mm cylindrical slab, means first construct the box, the outer box 50 mm. For example, it looks like 50 mm means this one. Okay, this is the top view of the striker, and the front view how it looks. The front view, the 20 mm thickness. It looks like this. This is called as orthographic projection. This is the orthographic projection, that is the top view of the cylindrical slab, and this is the front view of the cylindrical slab. So if I tilt this in 30 degrees, how it looks like a ellipse. Okay, now you need to put a box for this, that is outer boundary, and then you need to construct. Okay, so now take 50 mm. So this is the outer box. We need to construct this outer box in isometric projection. So if you want, you can name this The box dimension A to B is 50 mm. Similarly, B to C is 50 mm, like that. This is a cylindrical slab. We have put that in a box to construct for isometric projection. So this what I have shown here is the orthographic view, that is top view of the cylindrical slab, the front view of the cylindrical slab. Okay. So now I consider the base part A to B. It is 50 mm. 50 angle is 30. Next 50. So now, so I can name that. So I'll take B1 as the pivot point. This is C1. This is D1. This is E1. So take the from this corner to opposite lines midpoint, construct a line like this. And from here to here, opposite lines midpoint. And for this line midpoint, and this line's midpoint. So in manual construction, just use the dimension 50 mm into 25 mm. For this line 25 mm, for this corner to here, construct that. Now use a compass. From here, take this as a radius, cut an arc. Next from here, this as a radius, cut an arc. And next, taking this as a radius, cut an arc. And next from here, cut an arc. Okay, this is the base what I have created. Similarly, the top you need to construct. Again, go to normal line. The thickness is 20 mm. From each outer box, take 20 mm. Similarly, do the same procedure. So if you are getting confused, means erase this bottom completed supporting lines. Okay, and now go to arc by center point. scale, construct these two tangents. So this is a cylindrical slab of isometric projection. So this is for actual dimension, and for iso scale use conversion tool. It is here. But while constructing in a white sheet, each and every dimension you have to convert that by using calculator. It is 50 into 0.816 and thickness is 20 into 0.816. If you are using grid sheet, no need to convert. So take 5 boxes and 2 boxes vertical. No need to convert in iso grid sheet. So remove all the unwanted lines. So in manual construction, use a very thin pencil, erase that, and then afterwards whatever the required you can use a thick pencil or a 2B pencil. This is a cylindrical slab, isometric projection of cylindrical slab. Okay, let us construct some more problems in the next session.